Okay, let's start with this warm-up today. Classify the triangles with the given side lengths. Remember, to classify a triangle, we're going to use Pythagorean theorem converse. So we're going to write Pythagorean theorem backwards, c squared, and then is equal to, greater than, or less than a squared plus b squared. What is the thing in the top right? Oh, okay. So you know how you can't take a square root of a negative, like your calculator says, what does it say? Does it say unreal answer or something? So anyways, yeah, non-real answer. So did you know that all of our answers that we get in this class are real, but there are non-real answers? There are imaginary answers. I'm not making this up. Imaginary answers. So when you take the square root of a negative number, you get an imaginary number. Those are real things. There's like an imaginary number line too. So anyways, you get an imaginary number, and it's appropriately actually called lowercase I. The square root of -1 is lowercase I. So it's I love math. That's what it is. If just to let you know, because y'all like to know extra stuff, if you want to take the square root of -4, you'll learn this in later maths. The square root of -4 is actually 2i. Because the square root of 4 is 2, and the square root of that -1, that negative, is I. So it's 2 times I. Anyways, good information. Let me know when you're done with the warm-up. Facepalm. Okay, so we're classifying these triangles. Hey guys, before you classify them, you have to find which one is C. Did you already find which one is C? And number 1, is it 8 or is it 6 root 3? Are you asking your calculator? So I always like to circle the largest number to indicate that that is my C. Out of the A, B, and C, the largest number is going to be C. Good. And what about, it's pretty obvious in number 2, which one's the largest one? Okay. So now we're going to compare C squared to A squared plus B squared. It doesn't matter the order that you write the A squared and the B squared. The order does not matter. Now, some of us are still having trouble squaring 6 root 3. You're having trouble squaring a term that's in parentheses. Make sure you square the 6 and you square the 3, or just put the whole thing in your calculator. There's no shame in that. So what is it? 108, right? Because 6 squared is 36, and the square root of 3 squared is 3. 36 times 3. All right, and then we have 8 squared, which is 64, plus the square root of 5 squared. These are going to cancel, so it's just 64 plus 5. So this one is not even close. The race is not even close here. It is absolutely obtuse. When you get a greater than sign, the answer is obtuse. When C squared is greater, the answer is obtuse. When C squared is smaller, the answer is acute. Greater, obtuse, smaller, acute. Okay, what about the next one? This is going to be a large number, isn't it? Yeah. 28 root 2 squared. Everyone type their answer in. Ganesh was first. 1,568. And then 20 squared plus 21 squared. What'd you get? Yep, 841. Good job, V. Oh, this one is not even close either. It's even further apart. C squared is totally winning. And so they're both obtuse. You should have gotten obtuse, obtuse. 2 in a row. Let's check our homework answers. Here's the first page of answers. Give you some time to look at those, and then I will work as many as we need to work today. Oh, sorry, we're hiding it. Here's the rest of your homework answers, 12 through 18, and then you need to make sure that you have your questions ready. Which ones am I going to work? Have them ready. Okay, we're starting on number 6 from the homework. We learned yesterday that when triangles are right and isosceles, they have to be both. They have to be right and isosceles. We learned that there's a pattern. So since we learned about this pattern, It always works because you trust Miss Tanton that it always works. And therefore, we can use it and bypass Pythagorean theorem. We can bypass it every time. Okay? No, you don't, Johan. No. Okay, so on this one, we are given the hypotenuse. We talked about yesterday. When you're looking for a hypotenuse, you multiply by root 2. When you're looking for a hypotenuse, you multiply by root 2. When you're looking for a leg, you divide by root 2. And that's why y'all are in Geometry K, because some of these problems are not as pretty as 3, 3, 3 root 2. They don't all follow the beautiful pattern. We have to know how to find the missing sides even when the answer is not pretty. So I know that I'm looking for a leg. I know that I'm going backwards. So I know I'm going to have to take my hypotenuse and I'm going to have to divide it by root 2. I have to go backwards. I have to do the opposite of multiply. This is one where we have no choice. We have to rationalize the denominator. So in the numerator, we're going to have 5 root 6 because we're allowed to multiply 3 times 2. And in the denominator, we're going to have 2. This is an isosceles triangle. So once you find one leg, you have found both legs. Someone asked me if you're allowed to put 2.5 root 6. And I said, yes, you are allowed to, because 2.5 has an end. It's not a repeating decimal. It doesn't go on forever. So you're allowed to put that if you so desire. Now we're looking at number 8. Oh my goodness, we're in the same exact situation. We are given a hypotenuse and we're looking for a leg. So I'm not going to go over that again. I'm just going to dive right into it. We know we have to extract a root 2 out of it. We have to undo multiplying by root 2. We have to divide by root 2. Once again, you should get so good at rationalizing the denominator because we do it a lot. 12 times root 2 is 12 root 2. Square root 2 times square root 2 is 2. Heaven forbid we keep our answer like that because that is not simplified. You can actually divide 12 by 2 and we get 6. We know that they are both the same value because it's an isosceles triangle. So if you wanted to check your answer, you would say 6 root 2, 6 root 2, 6 root 2 root 2. Well, 6 root 2 root 2 is 6 times 2. It's 12. So we checked our answer. We're good to go. Number 9 is an important problem because you have to draw your own segment. And I want to show you what segments students draw sometimes, and it really does them no good at all. Are you watching? We have to create triangles. And a lot of students create that triangle, and that's all well and good. You can try to solve for parts of that, but you know what? That diagonal, drawing that segment, is not going to help us at all. In fact, I'm not sure we can even find that segment. So anyways, that would be the wrong segment to add to your picture. That would not get us anywhere. We do need to create a right triangle, but that's not the right triangle we want to create. This is the right triangle we want to create. Are you all noting what segment I added to my picture? I drew an altitude. Turn your head sideways. I drew an altitude. And I created a 45, 45, 90 triangle, which was very important. All right. From here to here is 26. From here to here is 14. I know I can take that 14, and I can drag it right over. So I know I can do 26 minus 14, and I can find the leg of this triangle right here. It's 12, 12, 12 root 2. I did too much work, but I just wanted to show you all the pieces. Okay, so x is 12. See that? X is 12 because we use 45, 45, 90 triangles to see the relationship there. 14 is another problem for which we need to draw some altitudes. We need to add some segments to our picture. We can draw an altitude here, and this is really not to scale, which kind of confuses me. Probably confuses you as well, right? Because that does not look like a right isosceles triangle, but it is. It is. Okay, so what can we do here? Let's see. We want to find P. P stands for the perimeter. We know this is 6 from here to here because we're just looking above. Now we need to work with this triangle. Unfortunately, that doesn't say 8 root 2. It just says 8. So we are going to have to take 8. We're trying to find a leg. We're going to have to divide it by root 2. So we're going to rationalize our denominator. 8 root 2 over 2. Oh my goodness. It's 4 root 2. We don't need to know that one, so I'm not going to put it. 4 root 2, 8, 6. Okay, this is so important. Is every single person watching, every student here. We're going to find the perimeter, and you're going to promise me you're only going to add integers to integers, and you're only going to add radicals to radicals, because that's all that's allowed. You wouldn't do this work every single time, but I just want to show you all that we have. We have 6 plus 8 plus 4 root 2 plus 6 plus 4 root 2 plus 8. I wouldn't expect you to write that addition sentence out every time, but we do need to make sure we are adding our like terms, right? So we're going to add 6 plus 8 plus 6 plus 8. Is that where we get the 28, right? And then, are we allowed to add 4 root 2 plus 4 root 2? Are those like terms? Yes, they are. It's like 4x plus 4x. What is 4x plus 4x? Well, it's 8x. So it's 8 root 2. And that is the perimeter of the figure on number 14. We would never add the 28 to the 8. Don't do it. Don't ever do it. Don't even think about doing it. I didn't get the edge of that one, but you can imagine what it looks like right there, right? Okay, here we go. Who knows what this shape is called, by the way? Who knows what this shape is called? Yeah, it's a kite. Very good. Okay, so we know that this is 45, 45, 90 because when it's both right and isosceles, it has to be 45, 45, 90. We can use our trick, x root 2. 6, 6, 6 root 2. Okay, well if that has a tick mark and it's 6, and that has a tick mark, then it has to be 6. So this is 6, 6, 6 root 2. Ooh, I spy a Pythagorean triple. Do you spy it? Look at this triangle right here. This is called a Pythagorean triple. 6, 8, 10. Over here, 6, 8, 10. If you didn't know it was a triple, you would need to go to the side and you would need to do Pythagorean theorem. All right, let's add all of our integers. Add them up. 10 plus 10, 20. Add all of our radicals. 6 root 2 plus 6 root 2, 12 root 2. You don't combine those. It is not 32 root 2. It is 20 plus 12 root 2. Last problem of the day for the homework, at least. The area of a square is 121. Find the length of the diagonal. So the area of a square is 121. You know that, I'll call this y. You know that to find, hopefully, the area of a square, it's just side squared, or length times width, x times x. So I know that x squared is 121. I also know that the opposite of squaring something is square rooting. So I know that the sides of this square are 11. Now, the funny thing, not the funny thing, but the great thing about a square is that when you draw the diagonal, you create two 45, 45, 90 triangles. That's not a coincidence. That happens every time. Every time you draw the diagonal of a square, you split it into two isosceles triangles. So what's the diagonal? 11, 11, 11 root 2. You don't have to do any math. Well, you're doing math. But you don't have to do any arithmetic or Pythagorean theorem because you use the pattern. Let's move on. Today's lesson is called Special Right Triangles 2. We're going to take what we did yesterday and we're going to make it a little bit harder. So get ready. Buckle your seatbelt, okay? Yesterday, our triangles were special. You can't use that rule on any old triangle. It works on 45, 45, 90 triangles. Well, guess what? There's another pattern out there. Patterns are great because they're shortcuts if we use them correctly. There's another pattern out there, and it doesn't work on 45, 45, 90 triangles. It's another triangle that shows up a lot in the real world, all the time, shows up, and it has its own pattern, and that's what we're going to learn today. So yesterday was all about a shortcut, and today is all about a shortcut. Find the missing angles of this figure, and you will know what today's special triangle is. Yes, okay. Y'all are too quick. So if we technically wanted to do the math, we know that this one and this one add up to 90, right? I hope we can all agree on that. So a plus 2a is 90. 3a is 90. So a would be 30. So we know that this angle would be 30, and this would be double 30, so this angle would be 60. So today's special right triangle, it's like an exception to the rule, it's special, is 30, 60, 90 triangles. Now I'm going to go ahead and just give you the rule. Here are the rules. It's not x root 2. It's a new rule. Can you kind of visualize where those side lengths would go? I'll put the angles back on. If those are side lengths, think about where they would go on our picture. Good. Okay. So out of all those numbers, which one is the smallest? The smallest one is x. The smallest side, if you remember from last semester, is going to go across from the smallest angle. The smallest side is going to go across from the smallest angle. So the one across from 30 is x. What's the largest number of all of those? Because we know the hypotenuse is always the largest. Is it a bigger number to multiply by 2 or to multiply by root 3? Which one's bigger, 2 or root 3? 2 is bigger. So 2 is our hypotenuse. And then x root 3 is the side across from 60. This rule is not quite as catchy. X root 3, 2x. X root 3, 2x. That's our rule today for 30, 60, 90 triangles. We're not going to do this. We're actually going to skip that because we are going to find it using Pythagorean theorem. But I don't think we need to discover it. We kind of did that the other day. So this is how the rule works. X root 3, 2x. And then on the other one, x root 3, 2x. Notice someone mentioned the hypotenuse is always double the short leg. Always, every time, 2x. I would do those two first when I'm solving for these. I would always tackle the short leg and the hypotenuse first because one is just half of the other. One is double the other. So just look at that relationship. 8 is double 4. 6 is double 3. 3 is half of 6. 4 is half of 8. Okay, so if you want to write this in your notes, this would be the one slide you would want to write down. X root 3, 2x, 30, 60, 90. X root 3, 2x. There is a poem. I am actually going to show it to you. All right, let's see if we can take this rule that we just learned and apply it to our triangles. Now, some of you are going to be able to look at this triangle, you're going to be able to know the missing sides, and you're going to move on to the next problem. Some of you are going to need a table to organize your information while you're still learning this. You're going to need a table. I will show you the table, but you don't have to use the table if it is kind of redundant for you, if it's too much work, okay? So here's what I do while students are still getting used to the rule. I make a small little chart, and it's x root 3, 2x, because that's the rule, okay? Then I always ask my students, which side do we have, and what is it across from? You'll get so tired of me saying that. Which side do we have, and what is it across from? Well, we have 11, and it's across from 30. 30, 60, 90. So I put 11 in the 30 column. I know that this problem is too easy to use the chart on. I just want to show you how to use the chart because you might need it for the tougher problems. Okay, so then once you put the side in the right column of the chart, you just follow the chart. X root 3, 2x. You just follow the chart. If any of the columns need simplifying, you would simplify them like this one. And then you just put the sides right back on the triangle where they go. You put the largest one across from 90, and you put the medium one across from 60. So A is 11 root 3, and B is 22. We were able to avoid Pythagorean theorem once again. If we had to use Pythagorean theorem, well, first of all, you can't use Pythagorean theorem with just one side, right? We couldn't have even solved this problem if we didn't know the pattern. Try this one. What do we have, and what is it across from? We have 24, and it is the hypotenuse. It is the longest side, so it goes in the 2x column. All right, so I know that 24 is 2x. If I know what 2x is, how do I get to x? Divide by 2. And then just follow the chart, x root 3. So whatever x is, whatever the 31 is, you just multiply by root 3. Put them back on your picture. The shortest one is j, so it's 12, and the medium one is k, so it's 12 root 3. 12 root 3, 24. Okay, let's see if we can get some tougher ones. Well, not yet. I won't do the chart on this one. Some of these you're going to be able to just look at the picture and you're going to know the rule. It's x root 3, 2x. So you might be able to just literally go to your picture, visualize the rule, and you might just be able to do it right away. I know that my shortest leg is 2, and then I always know that my hypotenuse is double my short leg. It's always double. So don't do the chart if you don't need to. Like I said, if you can do this right on your picture, then do it right on your picture. This is our x, right? Because it's across from 30. What do I have, and what is it across from? Root 3 is our x, so this one's a little bit different. Normally, we wouldn't put that one in that column, right? But root 3 is our x, so we have to be careful. I'm going to do what the table tells me to do. It says x times root 3. Well, this is x, and then times root 3. And then it says 2 times x. So I'm just filling out my table. Then you simplify if you need it. 2. What is square root 3 times square root 3? It's 3. So across from 60, it's 3. And across from 90, it's 2 root 3. So that one doesn't follow the pattern quite as nicely as we're used to. That one might help if we make the chart. F is 3 and E is 2 root 3. Double. The hypotenuse is always double the short leg. I'm going to give you a minute to try this one. So I told you to ask yourself every time, what do I have and what angle is it across from? What do I have and what angle is it across from? Unfortunately, we have an integer across from 60. This is our least favorite situation because the 12 goes in the 60 column. We don't like it when there's an integer across from 60, but we can handle it, okay? How would we get from here to here? Because you always try to find x first. You always try to find that short leg first. Every time, try to find the short leg first. Good. The opposite of multiplying by root 3 is dividing by root 3. So where I'm going to go off to the side, and I'm going to divide it by root 3. It's taking a really long time for it to show up. Okay. And then I'm going to rationalize my denominator. That is 12 root 3 over 3. Is that fully simplified? Nope, we have to divide 12 divided by 3, which gets us 4. So we have now found x. It is 4 root 3. And then remember, once you find x, to find your hypotenuse, it's super easy. You just double it. 4 root 3 doubled is 8 root 3. So now I know that A is 4 root 3 and B is 8 root 3. Okay? Next one, I have my hypotenuse. I'm going to work this one on the picture because I know that not all of you are going to use the table. I have my hypotenuse. You always get your short leg first. You always get your short leg first. So divide by 2. The short leg is half of the hypotenuse. So I know that D is square root 6. It's half. 2 root 6 divided by 2 is just root 6. And then I know the one across from 60 is x root 3. Oh, what is that? Square root 6 times square root 3. Which is so D is square root 6, whereas C is 3 root 2. Okay? We're doing okay? If you can stay in class, you can stay. If you need to go, you can go. All right. Ooh, 2 for 1. We have a 45, 45, 90 and a 30, 60, 90 all in one. Solve for x and y. In our 45, 45, 90 triangle, 15 is the hypotenuse. That's bad news because we have to divide by root 2. Remember, when you're looking for a leg, you divide, whereas when you're looking for that hypotenuse, you multiply. So to find x, we're going to have to do 15 divided by root 2. We're going to have to rationalize 15 root 2 over 2, or 7.5 root 2, either way. So that's x. We found x. Finding y is a little bit easier. Look, 15 is across from 30. That's our short leg. We know that y is always double our short leg, 15 times 2. So I didn't set up the chart there because we didn't even have to deal with the side across from 60. The hypotenuse is always double the short leg. Y is 30, whereas x is 15 root 2 over 2. Okay, a 30, 60, 90 attached to a 30, 60, 90. 12 is the hypotenuse. I know that this is 30, so I know that y is half of 12. And then I know that this one is x root 3, x root 3. Oh, now 6 root 3 is the hypotenuse. So if you have the hypotenuse and you're looking for the shortest leg, it's simply half. Hope we're okay with that. X is half of 6 root 3. So 6 root 3 divided by 2. Good. Okay, I'm going to save these for tomorrow, actually. The square in the equilateral triangle we'll save for tomorrow. Please try your homework tonight. Every problem of your homework. Have a good day.